Hello and welcome to 3.5, Implicit Differentiation. So far the functions that we've been working with are written explicitly as y equals in terms of one variable, right? Y equals some function in terms of x. We've had functions in terms of t. Okay. Now with this section we're going to try to find the derivative when we have functions that we cannot write explicitly or as y equals, or if there are functions that would be really difficult to write as y equals. Okay, like for example, when we have x's and y's mixed together in the same function, okay, such as x squared plus y squared equals 25, or another example could be x cubed plus y cubed equals 6xy. Okay, and there's various functions that we could implicitly take the derivative of. Okay, the technique involves basically finding the derivative of both sides of the equation with respect to x, and then solving the resulting equation in terms of dy dx or y prime, depending on what notation you're using. Okay, so let's take a look at the first problem that we have. Here we have x squared plus y squared equals 25, and we're trying to find dy dx. Okay, so for this problem, we're going to take the derivative of both sides. Okay, so take the derivative of the left. We would get the derivative of x squared is 2x. The derivative of y squared would be 2y. And then when we do the derivative of y, we have to remember to multiply by the derivative of the y itself, okay, which would be dy dx. Okay, one of the things you guys will notice when we do these derivative problems implicitly, for a native variable, like the x is a native variable to this problem because we're taking derivative with respect to x. Okay, so when we're taking the derivative of an x term, we don't have to worry about this additional chain rule piece. Okay, so when we take the derivative of a y term, then we have to remember to take the derivative of the base and multiply by it. Okay, and the derivative of 25 is 0, right? Derivative of the constant. Okay, so now we're going to try to solve for dy dx. Okay, so first we can subtract 2x from both sides. So we'll have 2y dy dx equals negative 2x. Next we could divide by 2y. And then we can simplify. When we simplify, we can cross out our 2's. So we have dy dx equals negative x over y. Okay, good. So that answers the first part of the question. Find dy dx. Next, it says find an equation of the tangent to the circle x squared plus y squared equals 25 at the point 3, 4. Okay, so we have a point, x1, y1. Now we need to find the slope at 3, 4, so we could just plug in three is our x, 4 is our y. Okay, so that means our dy dx is negative 3 over 4. Okay, so that's our slope. Okay, so that's our slope. This is like x1, y1. And so now we could come up with our equation for the line. Okay, so we would have y minus 4 equals negative 3/4 x minus 3. Okay, so that would be in point slope form. And then to get it in slope intercept form, we could just distribute the negative 3/4. So we'd have negative 3/4 x plus 3 times 3 is 9, 9/4. Okay, add 4. When we add 4, we're going to add, well, that's 16 over 4. So we have y equals negative 3/4 x plus 25 over 4. And that would be the equation of the tangent line at the point 3, 4. Okay. Let's take a look at this next example. Find y prime if x cubed plus y cubed equals 6xy. Okay, so let's get the derivative of each side. So when we take the derivative of the left, we have 3x squared plus 3y squared times dy dx, or let's do y prime since they want y prime, equals, on the right this will be a product rule, so we could do 6x times derivative of y, so 6x times y prime, plus y times the derivative of 6x, which is 6. Okay, so now we're going to try to get the y primes together on the same side. Okay, so let me first rewrite. I'm just going to rewrite it slightly. I'll put the y prime like this, plus 6y. Okay, so I'm going to bring all the y prime terms to the left, and I'll bring the other terms to the right. Okay, so y prime term to the left, so this will be minus 6x y prime. And then I'll bring the 3x squared to the right. Okay, so that means next we have 3y squared y prime minus 6x y prime equals 6y minus 3x squared. Okay, so what do we do now? We factor out the y prime from the left. So factor that out, y prime. Inside the parentheses, we're left with 3y squared minus 6x. Okay, and then next step, we're going to divide both sides by 3y squared minus 6x. Okay, so we're left with y prime equals, now we have the 6 and the 3's. We could divide all these by 3 to reduce them. Okay, so 6 divided by 3, that's going to be a 2y. 3 divided by 3, that's just regular x squared. That's gone. And then 6x divided by 3 is 2x. Okay, so then our derivative is 2y minus x squared over y squared minus 2x. Okay, so let's take a look then. That answers the first part. Find the tangent to the folium of Descartes. Okay, so this is Descartes' folium, they call this equation. Okay, so if you're ever looking up Descartes' Folium, that's the name of this equation. I'm looking for the tangent of that curve at the point 3, 3. Okay, so the point is 3, 3. Okay, so let's get the slope at 3, 3 first. So we're plugging in 3 and 3 into both x and y. So we have 2, 3 minus 3 squared over 3 squared minus 2 times 3. Okay, so that gives us 6 minus 9, so negative 3. And that's 9 minus 6, that's 3. So that gives us a slope of negative 1. Okay, so we have slope of negative 1. x1 is 3, y1 is 3. So we have y minus 3 equals negative 1, x minus 3. Okay, so now distribute the negative 1. Add 3. So y equals negative x plus 6. Okay, for the last part, let's take a look at that one. They want to know at what point in the first quadrant is the tangent line horizontal. Okay, so that horizontal tangent line, that's going to come from the equation for the derivative. Okay, so we have to set this equal to 0. So 2y minus x squared over y squared minus 2x. Now when we set this equal to 0, the only way this could equal 0 is if the top part is equal to 0. Okay, so this has to equal 0. Okay, so if we set that equal to 0, then we know that to get y, we would just add the x squared to the other side, and then divide by 2, so y would equal 1/2 x squared. Okay, if we take this now, this y equal to 1/2 x squared, we could take that and plug it into our original equation. Okay, so let's plug into our original equation. Okay, so our equation was x cubed plus y cubed equals 6xy. And everywhere there's a y, we're going to plug it in with 1/2 x squared. Okay, so we have x cubed plus 1/2 x squared equals 6x and then 1/2 x squared. Okay, so that gives us x cubed plus 1/2 cubed would be 1/8, x squared cubed would be x to the 6th equals, this will be 1/2 times 6 is 3, x times x squared would be x cubed. Okay, so now if we got the x cubes together, we could minus x cubed to both sides. we would have 1/8 x to the 6th equals 2x cubed. Okay, going a little further, we could multiply both sides by 8. So we would get x to the 6th equals 16x cubed. Okay, divide both sides by x cubed, and we would get 16 equals x cubed. Okay, so if we take the cube root of both sides, we will get x equal to, now the cube root of 16, that would be 2 times the cube root of 2. So in other words, we would have what? 2 to the 4/3. Okay, so x would equal 2 to the 4/3. If we plug that in to our equation, we would get y equals 2 to the 5/3. Okay, so numbers wise, if we did this on a calculator, this would be approximately 2.5198 and 3.1748. Okay, so let's take a look at the graph. So this is the graph of the folium of Descartes. Okay, this was the equation of the tangent line at 3, 3. Okay, y equals negative x plus 6. And then the point we're talking about where the tangent line is horizontal, that would be approximately right there, right at the tip of the... Okay, and that's about right. Okay, 2.5, so about halfway between 2 and 3, and then a little bit above the 3, 3.17. Okay, so that's what it would look like. Okay, let's take a look at example 3. Find y prime if sine of x plus y equals y squared times cosine x. Okay, so to get the derivative of both sides here, now taking the derivative of sine would be cosine of the same argument, and then we multiply by the derivative of the inside. Okay, now the derivative of the inside would be, well, derivative of cosine of x is 1, derivative of x is 1, plus, and then derivative of y is y prime. On the right side we have a product rule, so we have y squared times derivative of cosine, which is negative sine, plus cosine times derivative of y squared, which will be cosine x times, one second, okay, cosine x times 2y times y prime. Okay, so now our goal is to get the y primes together, and then we could try to isolate the y primes on one side. Okay, so here we have cosine of x plus y. Think of it as cosine of some argument times 1, and then cosine of some argument times y prime. Okay, so we have cosine x plus y times 1 would be itself, plus cosine of x plus y times y prime. And then here this will be negative y squared sine x plus cosine, we could do 2y cosine x times y prime. Okay, so we could bring the y prime terms to the left and then the non-y prime terms to the right. So we'll bring that to the left. We'll bring the cosine of x plus y to the right. So we have cosine of x plus y times y prime minus 2y cosine x times y prime equals negative y squared sine x minus cosine of x plus y. Okay, so now on the left we factor out the y prime. So that means we would have cosine of x plus y minus 2y cosine x equals negative y squared sine x minus cosine of x plus y. Okay, and then last step, we can divide both sides by cosine of x plus y minus 2y cosine of x. So we have y prime equals negative y squared sine x minus cosine of x plus y all over cosine of x plus y minus 2y cosine of x. Okay, let's take a look at another one. Finding a second derivative implicitly. It says here find y double prime if x to the fourth plus y to the fourth equals 16. Okay, so let's first take the first derivative, and then we could use this equation to then get the second derivative. Okay, so let me show you guys how that works. So for the first derivative, let's first write our problem now. X to the fourth plus y to the fourth equals 16. We want to take the first derivative, so we get 4x cubed plus 4y cubed times dy dx. Let's use y prime since the notation is y double prime. And derivative of 16 is 0. Okay, let's subtract 4x cubed. So we have 4y cubed y prime equals negative 4x cubed divided by 4y cubed. And so we end up with y prime equals, and we could cancel out the 4's, negative x cubed over y cubed. Okay, so that's our first derivative. Now let's take the derivative of this to get our second derivative. Okay, so second derivative, so this will be a quotient rule. So we have denominator times the derivative of the numerator. So numerator is treated like negative x cubed, so that'll be negative 3x squared minus negative x cubed divided by 3y squared, so times 3y squared times y prime all over the denominator squared, so y cubed, and we're squaring it. So when we simplify things a little bit, we'll have negative 3x squared y cubed plus, right, because we have negative over minus, this will be 3x cubed y squared, and then times y prime all over y to the 6th. Okay, next step we're going to do is, we have y prime in here. Okay, so what we're going to do now is replace that y prime with what y prime was equal to. Okay, so y prime was equal to negative x cubed over y cubed. Okay, so we're going to replace that y prime with that. Okay, so let's do that, and then let's rewrite the problem. We have negative 3x squared y cubed plus 3x cubed y squared all over y to the 6th. Okay, so to simplify it a little bit, we could have negative 3x squared y cubed plus, well, actually do minus because this is a negative times a positive, so put minus 3, and then x cubed times x cubed is x to the 6th, and then the y squared and the y cubed on the bottom, that would leave us with a y on the bottom, and we have it over y to the 6th. Okay, so now if we were to do, I want to simplify this. I don't want to have this complex fraction in here. So if I made this have a common denominator of y, I'd have to multiply by a y on top, y over y. So this y to the 3rd will become y to the 4th. And then I could pull out the 1 over y, right, and I could make that 1 over y join the bottom. Okay, so this will end up looking like this. Negative 3x squared y to the 4th minus 3x to the 6th all over y to the 7th. Okay, and then I could factor out negative 3x squared. that means I'm left with y to the fourth plus x to the fourth over y to the seventh. And what's interesting is we have a part of the original equation reappear in our answer here. So we're going to simplify even further. Okay, remember the original equation was x to the fourth plus y to the fourth equals 16. Okay, so this 16 I'm going to use to replace x to the fourth plus y to the fourth. Okay, so that means the final answer will be, if I do 16 in there, well actually the next to last step, so multiply the 16 times the 3, so that'll give us negative 48 and then x squared over y to the 7th. And that would be the final answer for the second derivative. Okay, any questions, just let me know. Have a good day, a good night. We'll see you soon.